The story of the discovery of cold nuclear fusion began on January 4, 2015, when McKane narrowly escaped a fatal crash. He was a passenger in a Subaru Forester, which lost control and cartwheeled 12 times down a 200-foot snowbound ravine. To his surprise, he and the other passengers were miraculously still alive. At that moment, McKane was struck with a vision of an unknown technology that would ultimately change his life forever. As one life ends, another begins. The journey to bring forward to the world cold nuclear fusion ironically began with a fateful winter accident. Prepare yourself, for this is the official story of the discovery of cold nuclear fusion and how it will change the world forever. The pursuit to discover nuclear fusion stems as far back as 300 AD, where Greco-Roman Egyptians attempted the art of transmutation using dyeing processing and making artificial gems, pearls, and imitation of precious metals. Early alchemists were also influenced by out-of-the-box thinkers like Aristotle, who proposed revolutionary new methods for turning base metals into precious gold. Today, we are still attempting to master the art of sustained nuclear fusion. This process, called transmutation, is the nuclear atomic rearrangement reactions, which synthetically turns one atom into another atom via electron capture. The process where the atomic nucleus absorbs an orbital electron causes the positively charged proton to transmute into a neutrally charged neutron. Currently, the only method of transmuting an atom is with bulky particle accelerators like cyclotrons or dangerous bombardment of radioactive isotopes. Whoever discovers the novel method for sustained nuclear fusion will change the course of the human race forever. Thus far, no one has ever pulled the elusive sword from the stone, till now. McKane's life was much different before the eventual crash. Owning his own privatized pole vault training center, he taught others the mysterious ways of the pole vault, an event where you propel up 10 to 18 feet into the sky with a fiberglass pole, thus momentarily manipulating Earth's gravity with the fundamental forces of kinetic versus potential energy. As a child, McKane was always aspiring to do flips and fly in the backyard and in gymnastics class, or in the later years, the pole vault. His gravity-defying passions stemmed from a very early age. His ultimate dream was to become a stealth F-22 fighter pilot, but his father always directed him to safer career pathways. Little did McKane know that the universe is 50% fate and 50% free will. McKane was destined to clear a unique crossbar that had never been cleared before, the discovery of cold nuclear fusion.
I got in a terrible car accident with my wife at the time, and we rolled down a mountain at Leavenworth, 12 times down a ravine. We cartwheeled down a snowbank. And when we got out of the car, magically we survived. When I got out, everyone was sitting there and it was snowing and quiet. And this vision just smacked me right in the head. I almost just died. I heard a whisper in my head and it said, "You almost just died and you didn't do the one thing we sent you here to do." And as soon as I heard that in my mind, I had this vision of this thing, this device. And I knew at that moment, my life was changing.
Driven by the relentless obsession from his recent revolutionary insight, this fateful vision drove McKane to lock himself in a garage for 7 years in the attempts to discover an ancient forgotten electrical phenomenon not known to many. This journey down the rabbit hole would ultimately lead to the discovery of a new type of cold electricity called the Quantum Kinetic Well.
And my friends were gone, my family thought I was crazy, I didn't have any money, and I'm like, dude, I made the wrong move here. And as soon as that happened, and I was like crying at the coil winder, because I was lost. I was like, okay, I'm gonna kill myself. I made the wrong choice. And as soon as that happened, I was basically on my knees, bawling. And then all of a sudden that whisper came back and was like, no, you're almost there, just do it like this. And I was like, there's no way that would work. In conventional electronics that I have been learning all this time for like 7 years, that would never work. But I was like, you know what? I'm at the end of my rope, I might as well. So I got up, and it felt like an out-of-body experience. I reconfigured everything and then plugged it in and turned the knob, and there was all this bubbles and, you know, hydrogen, oxygen, gas, and I'm like, wow. But the power was super low. Like, this was not electrolysis. This was something different. And I knew as soon as I turned the knob and I saw the reaction on the table, I was like, this is something very special.
With a discovery this important, McKane knew he had to take the proper delicate steps to verify the amazing new electrical phenomenon. He had to prove out his hypothesis.
As soon as I saw it, I was like, I've got to figure out why it's doing that, right? Like I went and read textbooks and was like reading all the terms and like, how and why would that happen? With this type of electrical configuration, why? And there it was causing a well, sucking in electrons, doing electron capture. Thus, the atomic structures were rearranging, there was transmutation, and we had to get it studied at the Department of Energy because we needed to know for sure. So we contracted the Department of Energy to do these experiments with us for over 2 years. And every time they got the data, they would call me and go, this doesn't make any sense. We don't really want to write the manuscript for you. You write the first draft. And I'm like, I am an artist, not a scientist. You're going to make me write it? And they said, just write the first draft. So I took all their data and I looked it all over. And remind, I'm not a scientist. And I'm just going through terms and learning what all the data was. Why did this one turn to this one? Why did that one go away? Why did that one go up? And as I was doing the research for like 3 months, I had the title of the manuscript, Electrophysical Transmutation, and I sent that draft to the Department of Energy. And they were like, that's what we thought too. We just didn't want to say it. What? So then we finished the publication and we got published in Nature.
With the revolutionary quantum kinetic well technology researched in a strategic partnership with the DOE and published by NPJ Nature magazine, McKane needed to assemble a team of reputable engineers, scientists, and investors to further explore the full potential of this new form of cold plasma electricity.
Initially, I was an investor, and through a mutual friend, was brought into this, getting to meet McKane and having a little bit of interaction with him. I felt, I'd call it a prompting to become a part of this, although I've been retired a couple of years, and I felt this is an interesting way to make a change in your retirement, to kind of step back out and into a role. And I enjoyed it. Initially, it was kind of a find your way with McKane and how to fit and so forth. But as I found the skill set that I have, it started to integrate well with doing some of the leadership aspects. That led to kind of a positional assignment, and then it's become more of a official representation through a C-level spot.
We got in early on some of the different concepts and stuff that he was doing, and tried to help, with some of the experimentation and look at some of the results and so forth. So yeah, I guess we could say we're kind of at the beginning.
Got into quantum kinetics back in 2020 during COVID. So Randy and I were talking about some things, and he said, hey, I got this project, would you be interested in going and meeting with this guy? And so we went up, we had some lunch and saw the experiment and really chatted with him initially about what are you doing? What are you trying to do? So that's how I got involved in quantum kinetics. And kind of from there, just my role and responsibilities were a lot of design of experiments and trying to figure out what are we doing and what do we need to do and how do those things correlate. My mechanical engineering background really correlates to what variables can we control, what variables can't we control, and making sure that our experiments are scientifically backed. So that's kind of the role and responsibility from the beginning with quantum kinetics.
With the alignment of professional engineers and helpful investors, McKane was able to take Quantum Kinetics Corporation into a new phase of marketing as the United States and Patent Office certified over 7 new patents. It was clear that McKane's inventions were able to supersede the prior art of hot nuclear fusion, or in this case, thermonuclear transmutation.
Well, nuclear fusion is the opposite of nuclear fission. Where nuclear fission, you take large atoms and you smash it with a neutron and it breaks it apart to release a lot of energy. Nuclear fusion is the opposite of that, where you take light atoms and you smack them together and then they fuse to release a lot of energy. But there's a third way called the Quantum Kinetic Well. We call it safe nuclear.
While trillions of private and public dollars have been spent on nuclear fusion devices, none have successfully proven to sustain nuclear fusion longer than 22 minutes. Nuclear fusion is proving to be difficult to control.
Well, it isn't anymore. What we've been able to do is create, through the modular reactor that we call the ARC reactor. We've been able to take limited input power and take it to massive output energy. And we call that process the particle oscillations as an energy generator.
The academic community and the hot fusion industry, they are using light gaseous matter like hydrogen and deuterium and helium, and they're spooling them up into a tokamak, which creates a lot of heat and a lot of, it's called bulk ion heating. And it takes the plasma and excites it to a heated temperature, and then they use magnets to confine the plasma that's heating up. And all these processes are complex. It's like teetering a ball on top of another ball. It's really challenging to keep it on top. It's like stacking stones. It's tough. You gotta be just right.
Hot nuclear fusion, which utilizes bulk ion heating, is inherently dangerous and expensive due to the excessive fast neutron flux it creates, making it extremely electrically expensive, ultimately keeping a viable method far out of reach.
The techniques used are destructive, innately destructive. And what they have attempted to do to mask the failure is to build sturdier equipment, but they're still applying the same failed science for what they're attempting to do. And so we are finding that while one company has been able to sustain nuclear fusion for 22 minutes, they actually have destroyed their equipment in the process. You cannot repeat this over and over expecting a different result. It's not going to change the fact that that's all they have to work with.
It's very expensive, the bulk ion heating, and it's very challenging to make it happen consistently. Where in our process with safe nuclear, we use Mother Nature's fundamental forces to induce the well, and it happens 100% of the time.
The cold fusion is going to be better because hot fusion, you have to do it at really high temperatures. You have to have really large buildings. You look at the hot fusion type places, they're in giant warehouses, where our cold fusion devices, they're tabletop, they're size of a paint can potentially. And so we believe that doing it at lower temperatures with lower heat inputs, lower electrical inputs, that's going to be better for sustainable energy versus some of the hot fusion stuff where the sustaining of that is a little bit questionable.
You have to put in a lot of energy, a lot of watts to get the reaction to start occurring inside the reactor. And so it's expensive, and then the energy that you get out of it from the fusion only meets about the same energy you put in. So you never do the break even. You never do this thing called over unity. So if you can figure out a way that uses Mother Nature's processes gently, she will fill in the void for you. Actually, the Mother Nature hates a vacuum. She always likes to fill it in. So if you create a vacuum, a special type, she'll fill it in for you for free. And then you have more energy out than you put in.
In cold fusion, you get localized heating bubbles. And so you get this localized heat that's released, but it's not an overall, the whole thing doesn't have to be heated up. Whereas when you look at hot fusion, you're talking about very, very high temperatures. You're talking about the acceleration of particles and very fast particles, and then they're trying to collide, and then you're trying to capture the energy from that collision.
When you talk about cold fusion or hot fusion, you have to put energy in. So you're either going to put in cold energy or you're going to put in hot energy. And so if you think about it, hot energy is like the sun or hot plasma. And that's very difficult to come up with, or it can be very dangerous. It's been done, and so we know it's been done, but it's difficult to do. Cold fusion may be also difficult to do, but it's cold fusion, but you got to put energy in. And the only cold energy that we really know about is electrical power, right? Electrical energy.
With McKane's newly discovered cold electricity, synthetic nuclear electron capture can be accomplished on demand, ushering in a revolutionary new science and technology innovation, which sets the official new standard for nuclear transmutation machines for the human race, thus paving the way to remediation of radioactive waste and a new form of sustained nuclear fusion.
The Townsend runaway effect is really talking about runaway electrons. So we didn't see that in any of our experiments, yet we were still able to form, transmutate radioactive atoms, or another way to say it is to edit the radioactive isotopes.
Whereas in cold fusion, what we're seeing is you get this potential fusion event from elements fusing together, but you also get this potential fission event where fission comes from the decrease in your atoms. So you're actually losing your atomic weight. So what we're seeing is that in our experiments, in our cold fusion, you're getting this potential fusion event and this potential fission event. And part of that example of, and the data that we've gotten from our national labs and our experiments, is that we have this uranium in our source water, and controlling our experiment, we're taking source water data. And then from that uranium, we're tracking it through the process. And after 24 hours, we're seeing a decrease in uranium, and we're seeing an increase in things like tungsten and lead.
These elements are these radioactive elements that are changing form. And so it's doing some work that is beneficial to us, because it's transforming, in this case, radioactivity, and it's turning nuclear waste into non-nuclear waste.
Safe nuclear fusion does a thing called transmutation, where it takes the atom and transmutes the nucleus into something new. So it turns a proton into a neutron, or even a neutron will turn into a proton. And this is called quantum thermodynamics. And if you turn on our reactors that don't need a vacuum chamber, they don't need high pressure, they don't need lots of electricity, you can change and transmutate the ambient air that has CO2 in it and transmute it into something else.
We envision going to Mars with this and taking it and starting out on a pristine planet and keeping it that way. No carbon emissions, no new nuclear waste. And imagine a place where we clean up the Earth, but we also start to expand outward and do it properly.
The technology is only limited to the imagination you put it to work. What that means essentially is, if you have an idea to do something like colonize Mars, this technology allows you to do that. You can transmutate the air of Mars and turn it into something else.
By creating a synthetic version of this dynamic quantum kinetic well process, the ARC reactor technology can control and vector Mother Nature's atomic cleaning mechanisms safely for a wide range of industry applications.
Our process with safe nuclear, we induce this thing called cold neutrons. These are like 1 electron-volt neutron vibrations that occur in our reactors, like the ARC reactor. So we have figured out a way to induce and vector, control the nuclear fusion reaction on demand by just turning the knob.
This technology is so groundbreaking because in attempts to do nuclear fusion, no one has been able to take the simplicity of what we've been able to achieve and turn it into something viable. We are very certain that we have a future that everyone would embrace, because this technology will do exactly as we're promising.
The pollution-fighting ARC reactor technology is poised to usher in a new era of safely sustained nuclear fusion for industry, including innovative radioactive wastewater treatment techniques through the world's first star-in-a-jar cold nuclear fusion isotope editing apparatus.
Can be described as so many different things. But when you look at things like the Earth's crust and the Earth's center, and you look at the nature around that, and how does, we find different elements throughout the crust. And so that's kind of where we look at it from the nature perspective. You also can look at things like the sun, and how does the sun keep burning? How does the sun sustain its burning? And there's all these theories that the sun's going to burn out here or there, or who knows when. But quite frankly, we don't have a full understanding of that. And so it's a potential effect of a sun effect or a star effect. Those are potential things that we're looking at for the elements, comparing what we have in our experiment versus some of these other things that happen in nature.
We found with our research that if you use seawater, we can create a fine dust powder that is a hydride. It's a carbon-dense nitrogen-oxygen hydride, which is the most powerful hydride in the universe. And the Department of Energy is really interested in getting this material, but they don't know how to synthesize it. To synthesize it, you have to use a particle accelerator. We use microparticle accelerators to induce this type of reaction, to get the sediment, which is useful in industry. You can use it for running cars, for getting hydrogen. You can use it for magnetic substances, for particle accelerators, new types. And there's a whole host of different phenomena that occur with safe nuclear fusion.
By utilizing the patented, trademarked, and research-verified quantum kinetic wells approach to atomic nuclear transmutation, the industry applications of the technology are only limited by the imagination. It is finally time for the human race to boldly step into a new world, a world with cold nuclear fusion at its core.
The line between inorganic chemistry and organic chemistry, that line between the two, that's where safe nuclear fusion resides. When you induce safe nuclear fusion, you can cross the boundaries and go both directions on that.
We're going to rewrite an entire sector of economics and physics. And really, this is just the beginning of something. I think we called it the door, is just opening to a vast new area beyond.
This is a gateway technology. So what that means essentially is if you open the door to the other field, to another farmland, a pasture that no one's been on before, that's what this is. Once you open the gate, you can now go into a whole new playbox of technology. And that's what we discovered. We just discovered the door.
The legacy systems and the economic shift, if they don't see themselves in it, then they're not going to be buying into helping it along. We understand that. But we also understand that this is what the people in the future need, our planet needs. We're bringing something that is a remediation for the mistakes of carbon emission and nuclear waste.
Fusion cars, or fusion spaceships, or fusion, home heating devices, or electricity generators, or anything that you need for industry, you can use safe nuclear fusion to induce this reaction and use Mother Nature's technology.
We understand enough of it now that we can apply this technology to things like propulsion, heating, on with nuclear waste remediation. But also we have a vision for the future of what this might do for humankind.